The Engineer's Report on Wind Turbines by Olivia Espinosa. What are the input, transfer, and output energies? The input is wind, since it starts up the process of windmill energy. The transfer is kinetic to electric energy. The output will be the electricity that goes to homes. How does a windmill work? The sun. About 2% of the energy from the sun is turned into wind energy. The sun creates wind because temperature changes air circulation. Wind energy is a form of solar energy since the sun creates evaporation that leads to different amounts of air pressure. When the wind goes through the blades, it makes them turn. The stronger the wind blows, the faster the turbine rotates. But still, the blades of most turbines will start turning at a wind speed of 3 to 5 meters per second, which is a gentle breeze. How does a windmill work? When the wind goes through the blades, it makes them begin to turn. This process creates kinetic energy. The stronger the wind blows, the faster the wind turbine rotates. The blades of most turbines will start turning at a wind speed of 3 to 5 meters per second. The blades turn a shaft within the nacelle, which is a box at the top of the turbine. The shaft turns a generator, which converts the kinetic energy into electric energy. When a transformer converts the electricity to the right voltage for the local network, after that, it is exported to the electricity grid of that area. Wind turbines operate on a simple principle. The energy of the wind turns 2 or 3 propeller blades around a rotor. The rotor is connected to the main shaft, which spins a generator to create electricity. The blades turn a shaft within the nacelle, which is a box at the top of the turbine. Some nacelles are large enough for a helicopter to land on them. The rotational speeds go from about 30 to 60 rotations per minute, RPM, to about 1,000 to 1,800 RPM. This is the rotational speed required by most generators to produce electricity. The controller starts up the machine at a wind speed of about 8 to 16 miles per hour and shuts off the machine about 55 miles per hour. Turbines do not operate at wind speeds above 55 miles per hour because they may be damaged by the high winds. This process creates kinetic energy. The shaft turns a generator which converts the kinetic energy into electrical energy. Then a transformer converts the electricity to the right voltage for the local network. After that, electricity is exported to the electricity grid of that area. How have scientists and engineers improved the source, and what is being researched? Scientists created longer and lighter rotor blades, with some reaching 95 meters long. Blades with curved tips were designed to take maximum advantage of all wind speeds. They use materials that are better able to support the stresses of high altitude and wind at taller towers, better control systems, more reliable gearboxes, and the digitalization of processes. In 1887, the first known wind turbine used to produce electricity was built in Scotland. The wind turbine was created by Professor James Blyth. It was a 10-meter high wind turbine, installed in his garden to power the lighting in his cottage, making it the first house in the world to have its electricity supplied by wind power. Computer simulation can be useful to companies as they look to increase the capacity factor of turbines. The software allows companies to help design blades online so that they don't waste time on physical models. As Keith Lodgen once said, if you go back 10 years ago, and look at wind power, and then look where it's at today, it's just dramatically different. He's a general manager at General Electric. Comprehension questions. What happens when the wind turbines begin to turn? Higher level question. How does power transform from wind to electricity that powers a house?